So here is a pump setup for another customer of ours. This customer contracts us to come into their facility and perform helium leak checks on their condenser. Here you can see the two pumps here in parallel connected to this common suction line. And our instrument is installed upstream of this elbow here, 10 or 20 feet away from this picture. So when we perform these helium leak audits, a common leak spot on pumps is at these bearing seals, and there's a bearing seal here, and the other ones aren't as readily visible, but there's one on each side of each pump. What these pump setups and pump skids do is they take the same seal water that is feeding the pump, and they'll plumb it right into these seals, and you can see one of these lines right here, the stainless line with a valve on it. So what it's meant to do is it provides that water that goes in there and creates a little water seal, so you don't get air leaking in through the bearing seal or the bearing right there. And typically at this plant, what you want to look for is you look into that seal area, and if you see water dripping out of the bottom of the seal, you know you've got good flow rate and you shouldn't have any air and leakage leaking into the pump cavity. However, if you do have leaks here, from the perspective of our instrument measurement, it would look like low pump capacity because this air is taking up volume inside this pump and reducing the capacity that can come from the suction line here. So at this point, when we see the condition that these bearing seals are in, we'll get together plant personnel, we'll make recommendations on how to sort of reestablish the flow to those seals so that we can get an improvement on the pump capacity and the performance of this unit. So when we first arrived, this was the condition that we were measuring with our instrument, what the pumps were pumping. You can see we're at over 3 inches of mercury absolute. And at this point, all 4 of those bearing seals are dry. So we'll take this information, we'll sit down with our plant contact, make recommendations, and working with the plant personnel. We got 3 out of the 4 seals flow rate reestablished, and you can see this improvement here as we get 1, 2, 3 of those flows going again. And you already got a condenser pressure reduction of a little under 1 inch of mercury. The 4 seal, we had a little bit more trouble getting that flow reestablished, but once we did, you can see now this is where the pump is operating. It now has a higher volumetric flow rate, and more importantly in this application is the pressure has been reduced greatly. You know, from starting at a little bit over 3 inches of mercury, and now it's down ranging between 1.5 to 2.25, and that's a very significant pressure drop. And this drop in pressure is actually a huge savings to the customer in terms of fuel usage, and gives them the ability to generate more electricity from their operating unit. The lower that condenser pressure is, the more efficient that they can produce power. So that manifests itself in less fuel usage to create that power, or more power output for the same fuel usage. This same plant has 4 of these units, 4 identical units there. So when we're on site and we're doing our audits, our leak audits, we test all 4 units, and it gives us the ability to compare the different units pump capacity to one another. And for this particular time frame shown here, you can see this: the unit one pump capacity again is having pump issues. As you can see, it's running at the highest pressure and generally the lowest volumetric flow rate.